Good morning everyone. In last video we have discussed about the entity and its type. In last video we have discussed about the entity and the type of strong entity and the weak entity. In this video we are going to discuss about the attribute. I am Sangeethapriya B from the Department of CSE IoT working in SNS College of Engineering. The attribute or the properties that defines the entity type. For example, roll number, name, DOB, age, address and the mobile number are the attribute that define entity type student. In ER diagram, the attribute is represented by oval. The types of attribute. First one is the key attribute. The key attribute which uniquely identified this each entity in the entity set is called as a key attribute. For example, roll number will be unique for each student. In ER diagram, the key attribute is represented by oval with underlying lines. That is, if I have a student database, I have a various students with the same name. So I can consider the roll number which is not repeated in any of the student. So it is considered as a key attribute. Next one is the composite attribute. The attribute composed of many other attributes is called as an composite attribute. For example, the address attribute of the student entity type consists of street, city, state and the country. In ER diagram, the composite attribute is represented by oval comprising of ovals. Next one is multi-valued attribute, an attribute consisting of more than one value for a given entity. For example, phone number can be more than one for a given student. In ER diagram, a multi-valued attribute is represented by a double oval. Next one is the derived attribute. An attribute that can be derived from other attribute of the entity type is called as a derived attribute. Example, age can be derived from DOB. In ER diagram, the derived attribute is represented by dashed oval. The complete set of a type student with the attribute can be represented as. Here the key attribute is roll number, their name, DOB, phone number and age, and the address consists of country, state, city and the street. Next one is the relationship type and the relationship set. A relationship type represents the association between the entity type. For example, enrolled in the relationship type that exists between the entity type, student and the course. In ER diagram, the relationship type is represented by diamond and connecting the entities with line. The set of relationship of some type is known as a relationship set. The following relationship set describes S1 as enrolled in CS2, S2 as enrolled in CS1 and S3 as registered in CS3. The degree of a relationship set. The number of different entity set participating in a relationship set is called as a degree of relationship set. The first one is the unary relationship, where when there is only one entity set participating in the relationship is called unary relationship. For example, one person is married to one person. The next one is the binary relationship, where there are two entity set participating in each relationship. The relationship is called binary relationship. For example, a student is enrolled in the course. Third one is ternary relationship. When there are three entity set participating in the relationship is called ternary relationship. The next one is the unary relationship. When there is an n entity set participating in the relationship is called as an unary relationship. The next one is the cordiality. The number of times an entity of an entity set participating in the relationship is known as a cardinality. The cardinality can be different type. 1-to-1, each entity set can take part only one in a relationship. The cardinality is 1-to-1. Let us assume that a male can marry one female and a female can marry one male. So the relationship will be 1-to-1. The total number of tables can be used is in 2. Next one is a surgeon headed by the HOD. That is, all the surgeons will be reporting to the head of the department, and that will be the one. The next one is one-to-many. In one-to-many mapping as well, where each entity can be related to more than one entity and the total number of tables can be used is 2. Let us assume that one surgeon department can accommodate many doctors, so the cardinality will be 1-to-m. It means one department has many doctors. Total number of tables that can be used is 3. That is, the surgeon department has a many doctors. Next one is many to one. When entity is one set, entity set can take part only once in a relationship set. The entity in other entity can take part more than once in a relationship set. Cordiality is many to one. Let us assume that students can take only one course, but one course can be taken by many students. So the cordiality will be n to 1. It means that for one course there can be n student, but for one student there will be only one course. The total number of tables that can be used is in the 3. Multiple surgeries done by single surgeon. The next one is many to many. When entity is in the entity set can take part more than once in a relationship, cordiality is many to many. Let us assume that employees works on multiple projects. Next one is the participation constraint, the total participation. The entity in the set must be totally participated in the relationship. For example, the students must enrolled in the course, the participation of students will be total. Next one is the partial participation. The entity in the entity set may or may not be not participated in the relationship. If some course are not enrolled by any of the students, the participation in course will be the partial. Here the diagram is explained. Thank you.